So, welcome to the 2014 Section B, Question 5 on transformation geometry. The figure shows the logo of a music app for a smartphone. The logo is subject to transformations in the following order: central symmetry, P to P1. So I find the center point, draw the adequate number of lines through the center point symmetry, and flip the distance over. Translation, P1 to P2, so where I move the image down to P2. Axial symmetry from P2 to P3, where I flip the image over an axis. And P3 to P4 is a rotation clockwise through 90 degrees. So find the center point rotation and move them around. Part A, draw the given figure. Part B, determine the image of the logo under each of these transformations. Right. So I'll begin anyways doing the question. Okay, so here's the size of our square is 40, and then 25 and 15. Okay, so 25 and 15 is 40. So it's a square. And it's a 30-degree line here for the open door in it. And then we can have drawing our diagonal. And how do we find the center? Okay, point of the circle. Well, it's in the middle of the square, and remember, diagonals bisect to find the center of the square. Diagonals bisect. So there's the center point of a square. Diagonals bisect. Could be a little bit clearer where it is, but it is safe to assume that, because it doesn't actually show you any information to say that it's in the middle diagonal. But look at it, say it's safe to assume. Now, the radius of the circle is 16 millimeters. So we'll put in our compass. We'll draw in our circle radius 16. Now, then we're going to plot out the points P1, P4, P3 and P2. So P1 and P4 are up 65, across 145 from P, and a further 100, 245. Okay, so I want to go across 145 and then 245. And up 65 for both of them. So there's P1, there's P4, and then how about P2 and P3? So P2 is over 90, okay, and down 50 and 30, so add them together. What's 50 and 30? And then P to P3 is over 90 and 70, so what are they to get added together? 50 and 30 is 80, 90 and 70 is 160. Okay, so we can plot our distances over here are 90 millimeters, okay, and a further 70 is 160. And then we can go down then our distance of 50 for P3. And down 80 for P2. And then we have them marked in. Right, so P to P1 is central symmetry. So I'd suggest only to move the adequate number of points. Here's P, here's A, B, C, D, E, and then the center point of symmetry. But we're not going to move all these. Remember that it's a square. That's the key thing. It's a square, okay, and it should remain a square. The image of the logo should remain a square, and it's 40 by 40. That's really the key thing what you want to remember. So I'm going to join P to P1 because P moves first to P1, and I'm going to bisect this line P to P1. So I'm going to take my compass. If you find it easiest, set it to the length of your line. That's what I do teach my students in class, just to set it to the length of the line. Yes, it's obviously massive when you're doing the bisector. If you're confident at it, you really get a good understanding. You don't have to set your compass to the length of the line. It can be halfway. I'll just zoom out there, and I'll just close down that menu there at the bottom. So hopefully you can see there. Okay, just 1 second there. Now, we can join where the arcs intersect to find the center point of symmetry. So here's the center point of symmetry where the arcs intersected. So all the points move the same distance about that center point, right? So we're going to do point A. So I'm going to put my set square on A. I want to draw a line through the center point of symmetry. Now, what should happen is A moves, okay, from the center point over here. So it should be somewhere about here. It should be exactly there, but that doesn't always happen for students. The key, I think, is to ensure that the distance from P1 to A1 will be 40. So I'm going to set my compass to 40, okay, and swing a line, or swing an arc, radius 40 from P1, and they actually happen to intersect on the line for me just simply because it's done accurately. But that doesn't always happen, so it doesn't. And there's A1. The main thing is that the distance from P1 to A1 on this line is 40 millimeters, and then we can heavy them together, okay, and there we go. Now the next thing is that line A to B is a right angle to line A1 to P1, so I'm going to do that now. So I'm going to take my set square, line it up with A1, P1. It's practically horizontal. And then I'm going to draw a line at a right angle to A1, P1 from A1. And remember, it's still a square and the size is still 40 by 40. So I'm going to mark 40 on that. But the question is, how do students know where is B, down here or up there? Well, you would put your compass or your set square on B, draw through the center point, and you would flip, okay, B over so you'd know it's underneath. Now, and you can see the way there how little minute inaccuracies can begin to take place. There's a very small gap between mine, and that's what I'm saying, how error can add up over the course of the question. Right, now there's B1. Now from this point we don't need to transfer anymore, because it's still a square. Okay, it remains a square. Okay, and it still retains its properties. Okay, this is point C. Now, the door comes from P to E. Alright, the distance from D to B is 15 millimeters. So 15. The diagonal joins P to B, the first diagonal. The door is hinged about, okay, the door is hinged about P to C. So to give students a good idea where D is, okay, to give them a good idea, draw your line from D through CP. Don't use the actual point, but just because I was saying we didn't need too many more points, but I might just add in one as an example of where it is. Right, so D should be along there. So it should be on this line. Now remember, what were we saying? It was 30 degrees. So the size is 30 degrees from P to A, 30 degrees. So we're going to line our set square up there. And we can mark in the line there, and from CP. And we can draw them in. And the diagonals join together. And the radius still remains 16. Okay, and it's heavy in the area of PAB, the circle, so that could be a common flaw, students. It's heavy in the area of PAB. And there, that's the central symmetry done. But the next one is translation. So I have a translation from P1 to P2. So translation from P1 to P2. So that is just simply where the image moves downwards. Okay, so P1 is going to move to P2. Now remember, okay, it's still a square. So there's the distance. So only plot the appropriate number of points. Okay, so I think you only need, okay, 2 points on this. P1 and A1 is all you need. So we're going to line our set square up with P1 to P2. We're going to slide A1 on. Okay, the image will remain parallel, and we know that it should be 40 by 40. So I'm going to set it to 40 long. There we go. There's A2. And then it stays the same. Okay. Stays the same, right? So there's D1, E1. There's the center point. Right, so P2 to C2 should be 40 millimeters. I should make a right angle to this line. Keep the properties of the square. So there's C2. And here's B2 on it. It's the exact same as going parallel from P2 to P1 and setting your compass to the distance of B1 or P1 to P2. Look, it's the exact same as the image moving. the exact same, but it takes out, it's better at taking out little bits of error. And so we can have that line there. Distance in is 15. Okay, the angle here for the door from P to E is 30 degrees. And then C to D. Join the diagonals for the center point of the circle. Let's set our circle back to 16 millimeters the radius. So 16 millimeters, and it's heavy in the area of PEB. So PEB. So that is here, E2, D2. Okay, and then P2 to P3, okay, is axial symmetry. Axial symmetry from P2 to P3. So I'm going to have to join P2 to P3. I'm going to have to bisect the angle. I have to bisect, or sorry, not the angle. I'm going to have to bisect the line. Don't mix it up with the old one. Okay, that could certainly be something students would do. I'll set my compass to the length of the line, swing from P2 and P3. To join them together. So here is the axis here. Now, let's move only the appropriate number of points. So let's aim to move, okay, C2 as well, and okay, we'll move B2 to get an idea where it is, and a reminder that P2 or the line P2 to C2 is at a right angle to C2 to B2. So we have to move perpendicular to the axis. So I'm going to, C2 is going to be somewhere along this line, and B2 is going to be somewhere along this line here. Okay, I know that what you call it, P3 to C3 should be 40 millimeters long. Okay, should be 40. Now I'm going to put my compass on the axis, flip it over. Okay, I'm hoping that's going to be 40 millimeters long. Now what I would do, okay, genuinely do, set your compass to 40, swing an arc of 40 from P3 until it hits that line there, and you can see the ways they're slightly off. That's okay, where you should mark C3, because you want to maintain the original properties of the image. That's really what you want to maintain. Now, B2 should be somewhere along here. So it should be somewhere in this area. But remember, it's got to be at a right angle to P3 to C3. It's got to be at a right angle, and it's got to be 40 millimeters long. So you can set your compass then to 40 again. Swing from C3. it there. So we'll keep that light and draw in P3 to A2. You don't need to bring that over now. Okay, 2. Heavy there, P3 to A3 is heavy. We do the door, our 15 millimeters. So I'm doing 30 degrees from P3. I put that 15 millimeters, that's on the wrong side. Good thing I noticed it there. That 15 millimeters should be here. So there's my 15 millimeters there. Then we can join the diagonals again. To draw in a circle, radius 16 millimeters. Now, this is B3. So we know this, this is D3, okay, and that's E3. So we know the circle is heavy in the area of PEB. So around here you'll see the bottom leaf of the logo. So it's heavy. Now, the next part is the central symmetry, which students find, generally students find the central, or sorry, not the central symmetry, the rotation clockwise to 90 degrees. Students find the rotation part the hardest. So, P3 to P4, rotation clockwise 90 degrees. So that means P3 will be rotating clockwise to P4. So this is where the arc is, so the center point should be there. So it should. So now, so on my little sketch earlier I put it on the wrong way. Center point should be here. So we're going to join P3, okay, or we're going to draw a line from P3 at 45 degrees to this black line, because the angle is 90 degrees. So if here's the center point of rotation, the angle up here is at 90, so 180 minus 90. Okay, these two lines are equal, it's an isosceles triangle, so 180 minus 90 divided by 2 gets you 45. So I'm going to draw two 45 degree lines from line P3 to P4. Now, here's the center point of rotation. And again, we want to only move the relevant number of points. Alright, so let's focus on just moving, okay, 3 of them for the time being. So we'll do A3. Alright, so I'm going to join A3 to, okay, the center point of rotation, and the angle of rotation is 90 degrees, so I need to draw a line at 90 degrees to that. Okay, and A3 is or A4 is going to lie along this line. What do we know? The distance from P4 to A4 should be 40 millimeters. It should be 40 millimeters. Now, as a rough idea, A3, if you put your compass on A3 and swing it around, it should be roughly there. Set your compass. Okay, so I'll zoom in a little bit on that. Set your compass to 40 to get an exact idea as to where it is exactly. Set your compass to 40, put it on P4, and look, for me, the exact distance of P4, okay, to A4 at 40 millimeters is right there. See the way it's a tiny bit off the arc? And that's how inaccuracies can build on. That's how inaccuracies can build in transformation geometry. The smallest one, okay, adds up as we go along. They can multiply a lot. So that's why it's important to keep it consistent. It's 40 by 40 the square. So we want to keep that targeted all the time. So there's A4. Now let's get an idea of where B3 is going to be. Rough, are we going up this direction or are we going down this direction? That's what students need to get an idea of. So I'm going to join B3 to the center point of rotation, and I'm going to draw a line at 90 degrees to that blue line. And B3 should be somewhere along here. B3 should be somewhere along there in that area. What we do know is the line B4 to A4 should be at 90 degrees to P4 to A4. It should be at 90 degrees, and again it should be 40 millimeters long. It should be 40 millimeters long. So there we go there. There's B4. Now we can speed up then. We know C is going back this direction. So there's going to be C4. It's at a right angle. We can join back to P4. There's C4. Now, here, point D will be along here, 15 millimeters from B. And we know we have to draw a 30-degree line from P. So 30-degree line from point P and C. And then we can join the diagonals. and then we can draw in our circle. So it's radius 16. There we go. Now I'll heavy them in and that'll be it done. So there we go. Cheers, thank you, and bye bye. Don't forget to like, share and subscribe.